We're asked to sketch this graph, y equals the modulus of ln 2x plus 5, where x is greater than minus 5 over 2. In fact, this is the natural domain, because when x is equal to minus 2.5, we're going to get ln of 0 here, which is not defined, and then it can't be any less than that as well. Okay, first up, let's just draw a graph of ln x. So all log graphs look a little bit like that. Then, if I think about what happens with the transformation, the asymptote is going to move from x equals 0 to x equals minus 5 over 2. In fact, the new graph is going to look a bit like that. This will actually be minus 2, because that's when we get ln 1. Okay, I think we're ready for the full graph, including the modulus. Okay, so again, I've got my asymptote. It's not going to change. And I can say that x equals minus 5 over 2. Now, where the graph is positive, it's going to remain positive. So it's going to look something like this. When x is equal to 0, we're going to get ln 5. So I can write here that it's going to be 0 ln 5. And then as I had before, it touches the axis at minus 2, so it's going to be minus 2, 0. Right, but where the graph is negative, the modulus sign makes it positive. So essentially we reflect it in the x-axis, and instead of it going down, it's going to bounce back up to the asymptote. So something like that. And I think that's a pretty good sketch. It's got the shape, it's got the coordinates where it meets the x-axis, everything. That was part A. In part B, we're asked to solve the equation modulus of ln 2x plus 5 is equal to ln 9. So ln 9 is just a constant. It's going to be above the intercept. I'm just going to draw, actually, I don't know why I'm making it dashed. I'm just going to draw a horizontal line, roughly horizontal, going across. And the log graph will necessarily reach it because there's no asymptote at the top. Right, so one solution is going to be here, and that's just when you can ignore the modulus and set ln 2x plus 5 equal to ln 9. And for these two things to be equal, it must be that the parts inside the log are equal, because ln is an increasing function. I can just get rid of it. You could alternatively raise each side to the power of e, which would cancel them out. So 2x plus 5 is equal to 9. 2x is going to equal 4. X is equal to 2. Or we've got this solution here. And that is going to be when minus ln 2x plus 5 is equal to ln 9. Because here the log graph would naturally be negative, but the modulus is going to bring another negative in to make it positive. So the left-hand side here is actually positive. And I can't quite set them equal to one another here. But what I'm going to do actually is make it minus ln 9, so times through by minus 1, and make it ln 1 over 9. When because I bring up the minus 1 to make it 9 to the power of minus 1, which is 1 over 9. I could alternatively have made it 1 over 2x plus 5 equals 9, but it's just easier to do it like this. So now 2x plus 5 is equal to 1 over 9. 2x is going to equal 1 over 9 minus 45 over 9, which is minus 44 over 9. So if I divide through by 2, it's going to be minus 22 over 9. Brilliant.